hello to the listeners. We actually couldn't manage to get this show off to a smooth start because Seb, what happened?
We winged it. And
you screwed up. Just accept it.
Okay,
it's okay.
Yeah,
we
sure.
accept your apologies.
I enjoy taking the responsibility for your mistakes. Don't worry.
It's good. When we fail, you fail solo, and when we win together. But we've been running a poll about the weather thing. Obviously, by the time the listeners listen to this, the poll will be over because
and the
only
weather will have
18 hours
changed.
Left. Yeah, exactly. And we asked the simple question of should we drop the weather segment? Here's why. Seb doesn't like the weather segment. I like the weather segment. Fortunately, 58.2% said to keep the weather segment. And with that, Seb, how's the weather?
It's too dark to tell at this point. Well, it was slightly rainy before earlier today. But yeah, I have to admit again. So I'm flying to Moscow tomorrow for the first time again in like 1.5 years. So I was kind of just locking myself in, preparing and going over some talks again for a change.
Are you excited? Oh, don't worry about locking yourself in. I'm sure when you get there, you'll be in lockdown. You'll be like, I've got to give a talk. Yes, sure. After the 15 days quarantine, you will be able to. I'm not going to talk much about the weather because it's the same as always here. Sunny, nice. But so yeah, let's move on to more interesting things like our guests today. Who are they?
Is Nat Pryce and Duncan McGregor, who are the authors of Java to Kotlin, a refactoring guidebook, and who've also done a bunch of other things in the Kotlin community. Welcome on the show.
Thank you very much.
Well, hello.
So I know who you are, but and I'm pretty sure a lot of people in the audience know who you are, and everybody that did your workshop at what was it, like 2 Kotlin comps or 3 Kotlin comps? Three, right? 3 out of 3. 3 Kotlin comps. You had the refactoring to Kotlin workshop, which was always sold out. So congratulations on that. Obviously, with me doing the marketing, it's very easy. It's quite easy to be sold out, but nonetheless, congratulations. Pat myself on the back there. So just tell our watchers. Do you say watchers? Viewers, and people that hear us.
Audience, I think is the term.
Yes. and listeners, a little bit about yourselves, so that you don't both go at the same time. Nat, do you want to start first, or Duncan, do you want to start first?
We'll both decide to start first. I'll start first. Duncan can then take all the credit at the end. I'm Nat Pryce. I've been using Kotlin one day at a time since just before it went from beta to 1.0. So Duncan and I, were working at a major scientific publisher. We were getting annoyed with some of the rough edges of Java, and we looked around at various other languages, and Kotlin stood out as the one that seemed to have the best community, the best support. At the time, we didn't know what would happen to it, but we decided to use it anyway. It was still in beta, and then we were very happy with it. And just as we had to take our application into production, Google announced that they were going to adopt it, and it went 1.0, and we didn't have to convert everything to Java. So we lucked in on a bit of a technical gamble, but since then we've been, I guess, talking about our learning journey, learning Kotlin in London, and then in Kotlin Conf around the world.
Yeah, Nat says I'm the reason that we adopted Kotlin, because he looked at me trying to use Java streams and decided, God, there must be something better than that. We both sort of come from a London extreme programming agile community, sort of been around since really the whole of the time of the JVM. I suppose we've been developing on the JVM and have been through sort of what used to be called programming, and then became object-oriented programming, and then became functional programming, and whatever we're doing now. Nice sort of mix, I think.
Yeah, in fact, we probably both adopted Java at around the same age as it was then, when we similar to how we adopted Kotlin. So I started in Java before it went 1.0, because I was working in academia at the time, and Sun were giving out very early versions of Java to academic partners. So we could sort of see what it did. And I was writing C++ at the time, so I was very happy to move on to Java and not have to worry about manual memory management.
Yeah, I was a C++ programmer as well. Yeah. Give me garbage collection or die.
Or Rust. But anyway, that's another podcast.
All right. Well, those I think those are all topics that maybe we can touch upon a little bit later. Okay, I don't think we've had a comparison of Rust and Kotlin on the podcast before, because they are, I suppose, a little bit different beasts. Let's maybe start with the with kind of the obvious questions. You folks have authored a book. What's that all about? How did that come about, and what is it? What's actually in it?
Well, I blame Hattie because I started writing a book quite a long time ago. It's just sort of on modern programming, I suppose. It was based in Kotlin, and Hattie had a look at it. And I sort of came to the conclusion that nobody reads books anymore, or that I couldn't write one, and sort of gave up on it a bit. In the meantime, Nat and I had, with the experience of migrating code, taking organizations, helping them adopt Kotlin, with the experience of this workshop that we ran at Kotlin Conf. And I believe that O'Reilly came to Hattie and said, who should write a Kotlin book for us? And he said, well, this idiot Duncan has been doing some writing, might try him. So they came to me, and Nat, obviously, author of another great book. So I came to him, and we decided to sit down and write what we knew. And what we knew was that Kotlin had sort of hit a sweet spot in the way that we programmed. So we had a way of programming Java that we'd sort of come to over the years, which was really around fundamentally immutable objects, fundamentally assuming things weren't going to be null, assuming collections weren't going to change, objects weren't going to change. And that when we came to Kotlin just did that for us. I mean, that was what Kotlin wanted to do.
Yeah, it's a lot of work to do that in Java, right?
Yeah, in Java you have to add things in order to make that happen. In Kotlin, that's just the natural sort of the natural way of things. And so yes, we thought, well, we could write a book on how on our style of Java, effectively, and Kotlin. We had experience of converting Java to Kotlin, and so this idea of teaching Java programmers A, how we would do Java, and B, then what that would look like in Kotlin seemed to be a logical angle, I suppose. And
we had adopted Kotlin on some quite large code bases. We'd initially picked it up to write some new proofs of concepts that eventually made it into production. But then when we picked it up again, we were working on much larger code bases that had originally been started in Java 8. But because they'd been written in this style where Java is being used in largely, where the domain model of your application is largely functional, surrounded by object-oriented code for doing the coordination, there was a really clear win in introducing Kotlin because it interoperated well. Data classes shrunk hundreds of lines of code into one. It was an easy sell, and the challenge then was, given the size of the code base, you can't convert everything at once. What is the best way of gradually introducing it into a large code base that's under continuous development? We were, deploying multiple times a day, supporting the business processes, and we had to be able to introduce Kotlin without breaking that, without slowing delivery, without disrupting things. So that was an interesting challenge, and also interesting. As we learned how to do that, we thought that would be an interesting topic for the book and a way of structuring the book as well.
At first, we had this brilliant idea that we would teach the Kotlin language through refactoring for Java, which was what our workshop was really. But then we discovered that was going to be a really big book, and it was going to take a lot of work, and we didn't want to write a really big book.
And you keep changing the language, so
language, and also there's some very good books on learning Kotlin, and so we decided in the end to focus on this idea of migrating Java and the way that you program and the way that organizations develop from one way to the other way.
So you've introduced Kotlin to many organizations, right?
think
You
that's
have
true
to say yes, otherwise I can't have a
Yes.
follow-up question. It's just like, it's not going to work, people.
So many organizations.
Yes, you have so many organizations. Based on your experience, is it true that folks basically start to write Java and Kotlin as they start to adopt the language? Would you say? Do you see what I'm saying? Like basically writing Java but using Kotlin syntax.
Yes.
Yes.
Yeah. Sort of Java and Kotlin clothing. Yeah. And I think
Yeah.
that was the key to the book, really. It's like one of the concepts we introduce in the book is the idea that a language, like a piece of wood, when you're doing carpentry, it has a grain. There are some things that are easy to do, and there are some things that are difficult to do. The more you work with the grain of the language, the easier it is. If you just Command Shift Alt K, boom, convert a file from Java into Kotlin, you end up with like some Java code, but with different syntax. But the design is still following the grain of Java, right? And if you just convert everything like that, you'll end up with a Java system with slightly, with different syntax, better syntax, and there's certainly advantages for doing that, right? The nullability is in the type system is a massive improvement over Java, but you're not getting the most out of it because Kotlin makes some things much easier. Immutability, functions, higher order functions. It makes that much easier than Java. Just working with immutable collections is so much easier. Making all your data by default immutable and pushing effects to the edge of your system is so much easier. So once you start working with the grain of Kotlin, there are further benefits than just the more concise syntax and the additional type safety. The whole system becomes easier to understand and easier to work with and easier to change.
So for someone who, again, when we look at the kind of the transition, right, the transition period from Java to Kotlin, is that a story where you would start gradually introducing like more and more advanced Kotlin features, like, or is that something where you like formulate a plan in advance of how you can combine all these fancy Kotlin features and then just turn the whole thing immediately into a completely idiomatic Kotlin thing? Like, what's the reasonable approach there in your folks' mind?
We can't afford to stop work on our projects and make them all perfect, right? We have code bases, and not only that, we have the skills that we have as well. We have the people in our teams. They know what they know. They have an existing style. We have to do these things gradually. We have to. And one of the great things about Kotlin, of course, is its fantastic interoperability with Java. I mean, if we'd had to point to one thing, I guess it was the reason we adopted the language. After all, it meant that we could take a relatively low risk approach. That you can always go back. You could keep this system here, this little bit of the system in Kotlin if it all fails. Never does, but you could. So yes, the idea of how you keep a system working while you change it, which bits to change first. Do you change the bits you're working in? Just say, well, every time we touch a class, we'll convert it to Kotlin, for example. Should you adopt that strategy? Should you look for the places where you would gain more mileage from re-architecting? Those are the sort of questions we ask.
But I think your point about the team is really important. Is that it's really quick to change the code, but changing people's design habits takes more time. Takes time to ensure that an entire team is working and lining up in the way that they're designing. And that is where taking a more gradual approach really pays off, because people can see the effect it's having. More people are working on the same code as it's changing. And so the entire team starts lining up in a different way of designing by habit.
I have a question. Like, as developers, we really love to work with very large old code bases, don't we? We don't like greenfield projects where we get to use new technology.
Well, some of us actually do, Paddy. Some of us do actually love working in old code bases.
But only if we can change them.
Yeah.
But I was wondering whether, the fact that you can take a large code base that is in Java and start to add Kotlin to it, does that incentivize developers to kind of feel as if they're on a greenfield project using some new tech while at the same time in their legacy project. Do you see what I'm saying? Like it's kind of like the incentive of, hey, I get to play with a new language, try new ways of doing things, and at the same time, don't have to rewrite my entire system from scratch.
Yeah, I mean, it must be like being a lorry driver, and you've still got to deliver the goods, you've still got to drive up and down that road every day. But when somebody gives you a nice new lorry, it's great, isn't it?
Yeah.
I've not seen a lorry for years.
What's petrol?
Yeah, I mean, I would never recommend, in my professional work, say just rewrite everything. Right? It's like so risky. So I think like Duncan said, like it's such a killer feature. The fact that you can slot a bit of Kotlin in, you have to change your build a little bit, then you can start adding some Kotlin classes. You can start converting things. In fact, that's the first chapter in the book, pretty much beyond the introduction, is we're going to just show you how to make it possible to now start using Kotlin in a Java project. And then the next thing is, right, now we're going to actually take one class. We'll show you how to change that into Kotlin. Okay, and now we're going to show you how to turn it into some more idiomatic Kotlin and so on. So that was the structure of the workshop, and that was like the way we start the book. And then we move on to more advanced features or more advanced sort of transformations, where we show how to move from sort of mutable beans into immutable values, how to go from using Java optional into using type check nullable interfaces and objects into functions, how you handle errors. Instead of throwing, you can return sealed classes, algebraic data types, how we move from open to sealed classes, and what the different sort of trade-offs are between having open classes with polymorphism, object-oriented polymorphism, and sealed classes, and sort of when statements switching over different instances or types, subtypes. And so we sort of take the viewer on take the reader on a journey through that, from the sort of small changes up to some more significant design approaches.
We wrote sort of separate chapters to the book, and one of our problems was like how we sort of approached writing in a different way, and we had to find a way to divide the subject up. But one of my favorite chapters of the book is one of Nat's, where he talks about migrating a certain sort of feature and leaving things in the Java code and putting things into the Kotlin code, so that even if you've added a new Java client for this thing, you can then migrate that. You can then migrate that to Kotlin, leaving this sort of long-term refactorings. I think is a fascinating subject.
Yeah, especially when you've got very large code bases. You can't just change everything at once. You're going to continue to have Java code that is depending on code that's being transformed into Kotlin. It's very easy it's very cheap to transform a piece of Java into Kotlin, and with some careful annotation, you can leave the Java code completely unchanged. And then we also show techniques about how to ensure that your Java code is staying conventional Java, following Java coding conventions, while your Kotlin code that's depending on the same classes can become conventional Kotlin and take advantage of Kotlin features like operator overloading or properties and all sorts of other Kotlin features. So while you're working in the old code base, it still feels like it used to. It's still completely natural to a Java programmer coming to it for the first time. Could be unaware that some of the classes they're using are written in Kotlin, but on the Kotlin side, you can use all of the productivity features of Kotlin to write your code more concisely, more easily, and more type safe.
Lee.
All right. So I think one other topic that's often on people's minds is, well, the whole functional approach to things, right? Everything from higher order functions to what have you. But I feel like this is maybe something that, especially again, if you have an older code base, that might be a little harder to retrofit just intuitively. Is that also something that you're talking about in the book?
Very much so. I mean, we came to Kotlin from a style of Java that was quite functional. Our aim is to start from in the book with examples that we consider sort of typical Java. I think, in fact, there was a tension between Nat and I. Nat wanted to start from the very best Java that we thought we could write and then convert it to Kotlin. And I wanted to start from the sort of Java that I was seeing in production projects and convert it to Kotlin, and then take that thing and migrate it. And sometimes we look at, like, here's some Java, let's make that Java more functional and then convert that thing into Kotlin. And sometimes we say, okay, we've got some Java, let's convert it into Kotlin and make the result more functional. Either way works quite well. As I say, I think we start from programming is easier the less things change underneath you. So we have a whole section, for example, on Java and Kotlin collections, and that even in Java, treating every collection as if it is immutable, never mutating a collection, at least never mutating a shared collection, for example, is a good policy. And we go through, okay, here's a Java example with a shared mutable collection. Let's refactor that, and now once we've refactored that and we're not sharing a mutable collection, now that becomes a Kotlin in read-only collection, and so now we can naturally convert that to Kotlin, for example. So yes, one of our aims, I think, was we've both been very involved in sort of extreme programming and refactoring almost as a way of life. There are books on refactoring, but not many books that are like showing the way that refactorings combine into things. How to do one refactoring followed by another refactoring. How you take a code base from one place to another through a series of transformations. Especially with IntelliJ, it's very, very good at this sort of long-term whole code base sort of things. And so showing the way that we have learned to refactor, and we've worked with brilliant people. So. Yes, not just single transformations, but taking a code base and over a whole chapter, the same code over a whole chapter from one place to another. In fact, sometimes over multiple chapters.
Yeah, it's funny you mentioned IntelliJ, and then you look at the what's the most used refactoring, and it's just rename. It's like, do you know that there's a whole bunch of other things inside IntelliJ? But
I mean, to be fair,
I use rename probably the most as well.
Yeah,
like how I put my thoughts into the code.
Yeah, sorry, let me rephrase. Like, in comparison to the other ones, the other ones are very rarely used. Like the proportion is very disproportionate. Like every time I talk to people about how you can replace inheritance with composition, and you can do that with an action in IntelliJ, they're like, oh, so you've got more than rename refactoring. Yeah, and we've got delete as well. Okay, I want to stay on the functional stuff, because I mean, I may be wrong here, but I get the sense that you both kind of like functional programming. Am I spelling this correctly?
I mean, I don't think we're zealots. I think what we've discovered over the years is that really there are two ways to manage change. You either don't have things change, or you are able to observe all changes. And so there is sort of like a UI paradigm, the sort of small talk model view controller way of looking at things, which is that will allow everything to change. And you really need objects to do that sort of thing, right? You need to be able to talk to an object and say, not only what is your state, but tell me when it changes. And that's one way of programming. And I think, object-oriented programming grew up to support that. It grew up to support modeling in Simula. But there's another whole strand of programming which is really based around sort of data and calculations, which is where you say we are nothing changes. If nothing, if data is just static, then whenever we ask a question, we get the same answer, and that's really amenable to refactoring. That makes everything. It's really easy to refactor because it doesn't matter when you do a thing. I've been very influenced by a chap called Eric Normand, whose view of the world is that functional programming is about differentiating between data, we call them values, things that never change, calculations, and calculations will always be true because they're always working on the same data, and actions. And actions are just the things that change when you ask them. So if you're writing something to a database, it matters when you do it. It will change the answers to questions you ask later on. Now we need those actions. We need to write data. We need to do I/O, but a focus on when we're doing those things very deliberately, I think, is the important thing. And so there's a case for functional programming, there's a case for OO. We want to be able to solve problems by passing messages and asking objects to do things. That's still absolutely a thing. But we need to be wary of those things because they prevent us from changing code, refactoring it into other forms.
Okay, so I'm going to follow that up with another question, which is, what do you think is missing in the language when it comes to support for functional programming? And do you, I guess I know the answer to this, but I'm going to ask it anyway. Do you use Arrow?
We don't, well, I don't. The book doesn't. The book is very much showing the principles of a functional approach to design within the grain of Kotlin, without any compiler plugins or using coroutines in clever ways to fake monadic bind. So, in the work we do, depending on the context, we've worked in the JVM for everything from embedded systems with very small amount of compute up to big enterprise and grid compute systems. So, but performance is something you do think about, and the sort of way that you fake monadic bind with coroutines is super clever, but the performance is just not there yet. Right? So
okay, you're going to have to. Sorry, Nat, you brought it up.
No, you are going to have to cut an entire section of this podcast, and that's the bit you're going to have to cut.
the way that you turn flat maps into like full comprehensions in Scala, right? Which is just a nice syntax for doing flat map. Okay? Arrow, I don't know if it still does because I've not actually used Arrow for a while, so possibly the 1.0 release behaves differently. But when I was looking at it, it had a very clever way of pretending to do a Scala for loop for comprehension, using coroutines to bind the flat maps together in a nice linear code. If you write just flat map in Kotlin, you end up with these very, very deeply nested flat map, and then inside that flat map, and then inside that flat map, and it's gone right off the page, all right, back in again, right? And that's really impractical.
Which kind of defeats the purpose in a way as well, right?
Exactly. And so, full comprehensions like in Scala or other languages, are a syntax that allow you to write, use flat map, but be able to read it afterwards. Now we don't have that in Kotlin. So we talk about how we approach using a functional style, but within the grain of Kotlin. So Kotlin has inline functions. It allows you to do early return. So we do talk about the trade-offs, right? You can do an early return if you are writing a flat map over your own type, but you don't want to have these deeply nested things. You can have inline functions and do early return, and that's the Kotlin grain. The Kotlin sort of pushes you down that direction. Because of the design of the language and the trade-offs that it makes. The advantage is it's very easy for Java programmers to learn because it doesn't have extremely complicated type system. The type system is pretty much equivalent to Java's. So the way that you structure your modules and plug things together is very similar to the way you would do it in Java. But if you take a more functional approach because your data is immutable, it makes it more convenient. But we're not going down the whole category theory route. And that's the style that we approach in the book.
Can you explain what category theory is?
No.
I've got a great deal of respect for for Arrow, and I mean I contributed a bit to it. I used it on one project. The problem I have is that I just don't think in terms of monoids and applicatives. I think in a sort of imperative way, and then say, okay, how can I reduce the amount of mutation that's going on here? How can I reduce this to this idea of actions and calculations? How can I make more of my system a calculation and not how can I compose it out of bits and pieces? So I don't think of my programs in that sort of mathematical way. I think you have to look at thinking in terms of sort of a calculus, thinking in terms of the invariance in your program and so on. I think that's very useful, but as I say, the functional programming vernacular I don't get. I I don't think of how to compose my problem. I can't imagine saying, here's the program, and I wish to be able to change its concurrency model, but really not change anything else about the program. I can't cope with that. So and I don't, and I guess, the Java programmers who will read our book and adopt Kotlin aren't going to be in that category either. So luckily, we're off that hook.
There's a joke to be made there, but I'm not enough of a category theorist to make it. I think there are certain areas of domains where a very mathematical approach really helps. I work in finance at times. I have done, and I do at the moment. And there's certainly areas of the domain there, how you represent money and contracts and things like that, which naturally allow for a compositional way of modeling. But sometimes the world is just too messy. And so it's about finding the balance between how you represent things as a calculus, that composes nicely, and how you just model the messy real world of human relationships and all of that messy side of things, and find the right balance between them.
Now, as Hadi, you promised to give us one feature from Kotlin, like make one thing come true, and then we get onto Arrow. I think type classes is probably the place that I wonder where the language is going. Is it Keep 87? Started off as type classes, ended up as dependency injection. I never quite understood how. We now seem to be onto multiple receivers. I think multiple receivers is still type classes, I think. But ad hoc polymorphism is the thing that the language is really sort of missing, right? The ability to say, we can have it a little bit with extension functions, but that's not, we don't get to control how that happens. And so
having polymorphism, not object-oriented style, like dispatch, not attached to a class would be great. Yeah.
The ability to adopt an interface effectively.
Yeah. Higher kinded types would be nice as well, and then you would be able to go full on the, for a bit until you started getting onto all the other things that people have added to Haskell over the years that people will then start demanding. I mean, that is the problem with static type systems is, you always find something that you really feel that you should be able to statically type, but you can't. So you want to change the type system, and then I also want to statically type this thing too, and you can't, and so you have to change it again.
Okay, but then where do you draw the line? Because from one side, you're saying that, one of the benefits of Kotlin is that the type system is easy to understand, that it's familiar for Java developers, that, but from the other side, you're saying, well, let's kind of try and bring in, or these concepts are missing, right?
The line has to change over time, I think, right? It's people's approach to programming changes. People learn different things, and it spreads throughout the industry. There was a time when Java garbage collection was just an absolute no-no, and then that was really popularized by Java, I guess. Although other languages had it, they were all not mainstream, and people changed the way they design things as a result. And I expect that the functional approach will spread through the industry in a similar way, and languages will slowly, adopt different features and as they, as people expect those features in their languages.
I mean, we've learned to cope with higher order functions, haven't we? I mean, that's not a thing that is sitting around in C. It kind of wasn't in C++. It wasn't in Java for a long time. You could see how it was faked with sort of implementing interfaces and inner classes and so on. But we have, as an industry progressed, we've learned to deal with that stuff. I think that right now, I think type classes is probably the place, right? If Swift can cope with type classes, then Kotlin could probably cope with it.
I have one more question, actually, because, well, when we're already talking a little bit about, how languages are going to progress, I was wondering, did people already kind of approach you also in regards to the content of your book? And was there something that they found particularly surprising, or something that they maybe didn't expect?
I don't think so. Maybe we're just too predictable, Duncan.
They didn't expect the Spanish Inquisition.
Nobody expects the Spanish Inquisition.
We did when we signed up for this podcast.
I mean, we've had some quite nice feedback on people saying that this really helped them understand a sort of more modern way of programming. Because I think we started not just from here's an abstract problem and here are ways of solving the actual problem, but here is a thing that exists in Java. And here is how we can take that thing that is in Java and either refactor it first, then convert it to Kotlin, or convert it to Kotlin, then refactor it. You can see the way that there's a problem that has been solved, and now there's a different way of solving that problem, and the new way is shorter or quicker or more easily understandable or easier to take in a different direction. Those sort of things.
And we every chapter starts with a problem from a business domain. So we have a single business domain running through the book, which is a sort of travel planning application. And so we will talk about like, okay, this part of the application is doing this. Here's how it's currently modeled. Here's some of the issues with that. Let's like see how we can take that in a better direction by turning it into Kotlin and then applying some idiomatic Kotlin. So each time we start with some idiomatic Java, and then we will move it into Kotlin and turn it into idiomatic Kotlin by small gradual steps.
You said you had a couple of people already give you the feedback that it helped them understand. Maybe one of the interesting questions there would also be, what do people find kind of the hardest maybe to understand?
Yeah, we'll have to wait for some negative reviews.
Oh, they were all just glowing. Okay. Well, we'll take
Currently,
it.
we've only got 3 reviews, I think, in total. So if anyone reads it and wants to give us a review, please do. Amazon is always, and Goodreads are there for us. And we've had friendly reviewers while we were writing it who were giving us feedback on what they found difficult to understand in the book and how they would like things simplified or broken apart into separate sections. So I think that's where we had most feedback. And we took, we took as much of that on board as we could while in the time that we had available and tried to address it. So hopefully the work of all of our reviewers who are all in the acknowledgements will have really paid off, because we did get a lot of excellent help from people who were reviewing the book while we were writing it.
And I'm assuming that all of those reviewers did get their complimentary copy, right?
We haven't had our complimentary.
We haven't even got a copy yet.
Okay, I'm just saying that I haven't even received my copy. I'm just saying.
No.
You'll definitely get one, when the trucks bring them into the UK. So,
I mean,
sometime in 2023 or something.
I'm not even talking about a cut. I'm just talking about a copy. I mean, Duncan, you did say that it was my fault that you wrote this book, right? So I get the good parts as well. Oh, imagine if in a few years you kind of like Kotlin, the good parts. And the book is thicker than the original one. Anyway, so listen, I used to ask this on the podcast very early on when people, when Kotlin just came out, right? And people started to use Kotlin. But I still think it's very relevant question, especially to you two that have essentially written the book. What is your recommendation for someone that is on a Java code base and wants to convert to Kotlin? Where would they start? And please don't tell me from the tests.
I say people always say the tests, don't they? But the tests are like always like the most valuable part of your code base. The tests are the places where, and one of the reasons for saying the tests, and I do support this. People say the test because they say, well, it doesn't matter, right? You can start with the tests, and if it goes wrong, then you could always just like convert the test back into Java, right? But the thing about the test is a place where you are trying to express normally the combinatorial behavior of a bunch of different bits, right? You've taken a system, and your system is this complicated thing interacting with this complicated thing, and there's an emergent behavior from that. So that's the way that sort of object-oriented programs work, right? And now your tests then, to the extent they test those two things, are trying to express that complication. And so your tests need to be really expressive. And so actually that is a good reason for writing your tests in Kotlin, because Kotlin can be really beautifully expressive, especially in tests. So don't not do your tests, right? But don't convert your test first because you think that's a low risk thing. Convert your test first because that's a really high value thing.
But I'm guessing the majority of people that respond with tests are the former. It's it's a low
Yes.
value thing. It doesn't really matter.
No.
I'll start with that, and if it goes bad, it's
I mean,
okay.
the lovely thing about Kotlin, and we all love it for this, right, is that it can be a really beautifully expressive language, and so your ability to communicate what your system is doing in code in your test is really, really important, and that's a really good place to start.
But the first time we did it, we started with a domain model because our domain model was very amenable to converting to Kotlin. It was largely functional, so we got a lot of bang for the buck. We reduced hundreds of lines of code of immutable Java, where classes had methods to return slightly changed copies of them for various business domain reasons, into a data class where all that's done for you, right? Test data builders in our unit tests could be replaced, once we've done that, could be replaced by constants, because the data class has the methods on it to allow you to easily change them. We could add some extension methods where we wanted some more methods for test data builders that were closer to the domain rather than the individual fields of the class. But that's suddenly we've shrunk hundreds and hundreds of lines of code down into 2. Brilliant, right? Or maybe a few extension methods as well. Places where you're working with collections. So the next thing we did was streams, turning streams into just using Kotlin's extension methods on collections. That's a big win. In terms of sort of simplicity, the whole going from a stream collection into a stream into a collection, and when you've got split iterators involved in there and everything, it's mind-boggling in Java, but much simpler in Kotlin. Then and the nullability. That what we found was we started introducing Kotlin. We were using optional in Java, so we had sort of classes using optional. So then we would start pushing out the Kotlin, and we could start removing the optional as we went and replacing it with strongly typed nulls. And there was a sort of a boundary that was sort of spreading through the code, where inside it was all null safe, and then we were converting to and from optional. And those 2 little helper functions of optional to nullable, nullable to optional were the last ones to go, really. I think that was the last bit of Java that disappeared when we finally had removed all the Java from the code base. But that sort of spread out, and then as it hit some of the more object-oriented parts of our system, handling HTTP requests or messages or things like that, then we would start introducing Kotlin into those and making it more OO Kotlin rather than functional Kotlin, but then still getting all the type safety and the concision that Kotlin brings.
Yeah,
that was the experience on that particular project. But other people have taken other routes.
We're big fans of extension functions, and I think when you look at a Java code base, it tends to be you've got objects with methods on them, and in the end, that object has to have the things that it knows how to do. But then there are other things you want, and they end up in things like the Java collections class, the ones that do sorting on things, and the things that take a thing as their first argument and then do things to it. They end up in utilities and so on. And the problem with those is that they don't get called in the same way as methods, and so you can't chain them in the same way. You end up turning your brain inside out as you try to work your way along a call chain. You do this, that, but then I step back out here and so on. And so we're big fans of extension functions, and just taking a set of Java utilities and rewriting that in Kotlin as extension functions. It can still be used as static functions then in Java, but all of your Kotlin code can start then chaining these things together nicely, just reading from left to right.
And they're more discoverable. But the other drawback of utility classes in Java is that you've got to know they exist before you try and call one, right? So in large code bases with big teams, then what happens is people forget, or don't find them and write them again, and you end up with various copies of them, right? Well, IntelliJ searching for extension functions means that you type, what can I do to this thing? And suddenly you've got the methods, and then all the extensions that are further away, and that makes such a difference.
Yeah, and you just gave me a brilliant idea. We should write a plugin for IntelliJ that when someone searches for a class that named utility, they're like, I didn't find it, but I found this other one called helper. Is this what you're looking for?
I was just going to say that extension functions and null safety and the null safe operators then start playing very nicely together. So you can now chain nullable things. It's much easier to call an extension function through a nullable reference than it is to pass a nullable reference, potentially nullable reference to a function that can't be called with a null. And so suddenly and this is, I think, where this is one of the inspirations for this concept that we put in the book and based the book around the idea of the grain of the language. It's like these two concepts of the language, extension functions and null safety, suddenly plug together and become more than just the sum of their parts. They work together really well to push the design in a certain direction, to make you write more extension functions because they're convenient to use. But extension functions can have shorter names than the utility class static functions would need in Java. So suddenly your code is getting shorter, it's getting more expressive, it's more type safe, and this becomes a sort of virtuous circle that sort of pushes the design in a certain direction.
Yep. Anyway, folks, we're out of time. Well, we're over time. That's the beautiful thing about this webcast. We can just go as much as we want or as we want. But we do try and keep it under an hour. I'm really excited for the book. Congratulations. I think that if it's as successful as your refactoring to Kotlin workshops, it's going to be a massive success. Please make sure my copy arrives so that I leave a good comment on.
Do you want it signed or left valuable?
Bloody hell, of course I want it signed. They're not going to send me some crappy copy that I could find a PDF online and print it myself.
Head over to
I don't
Reddit,
even have to pay for it then. Anyway, folks, thanks for coming on and congratulations on the book.
Thank you for having us.
And for everyone else, don't forget to subscribe, hit the bell, notification, all those things that Seb loves that you do. And we'll see you on Twitch. No, we won't. We're not doing Twitch yet, are we?
I don't think so.
No, okay.
Maybe in the future. Who knows?
Yeah, maybe. Until next time.
Bye-bye.
Bye-bye.